In an airplane crash, a woman is holding an 8.18 kilogram, that's 18-pound, baby. In the crash, the woman experiences a horizontal deceleration of 88.2 meters per second squared. How many G's is this deceleration? How much force will the woman exert to hold the baby in place? So I'm going to draw the chair here. This is the airplane chair, real fancy. Da, da, da. And here's the woman sitting down. And this is the baby, and she's holding it. I know it looks almost like she's pregnant, but let's just say the round thing is the baby because I have no artistic skills. All right, so she's going to slow down, and her acceleration is going to be 88.2 meters per second squared. But nothing's holding on to the baby. I mean, she's slowing down because she's in a seatbelt. According to Newton's first law, an object in motion remains in motion. So that is, the baby is going to accelerate, or seem to her like it's accelerating at 18.2 meters per second, or 88.2 meters per second squared. All right, so let's look at what we're given here. We are given that the mass of the baby is 8.18 kilograms, which is 18 pounds. We are also given that the acceleration is 88.2 meters per second squared. The first question is, how many G's is this deceleration? So a G to a scientist is just 9.80, and then it's meters per second squared. So this is the acceleration due to gravity on the surface of the Earth, 9.80. And we use this as a counting number. Like if I had if I had 8 rocks and someone said, how many pairs of rocks did you have? I would say 8 divided by 2, I have 4 pairs of rocks. If someone, let's say I had 18 donuts left on the table, and someone said, how many dozen donuts do you have? Well, a dozen's 12, so 18 divided by 12, that's 1.5 dozen. So if someone says the acceleration is 9.80 meters per second squared, and they asked how many G's is that, that's 9.80 divided by 9.80, so it's 1 G of acceleration. So in this case, when I'm looking for how many G's it's looking for, so the G's is going to be my acceleration, and then that is going to be divided by, whoops, I was really off here. The G's are going to be the acceleration, which is 88.2 meters per second squared, divided by the value for 1 G, 9.80 meters per second squared. All right, when I do the math here, I get 88.2 divided by 9.80. That's actually 9 G's of acceleration. Okay, so that's the first question. Second question, how much force must the woman exert to hold the baby in place? So if I'm doing F equals ma, I've got to use standard SI units, which means I'm not going to use anything over here with the units of G's on it. Instead, I'm going to have to use the 88.2 meters per second squared. So I'm going to use Newton's second law, F is equal to ma. It's already isolated the unknown, which is F. That's going to be the mass, 8.18 kilograms, times the acceleration. And again, I'm not going to use the 9 G's. I got to use standard SI units. So that's going to be 88.2 meters per second squared. And then when I do the math on this, I get a force equal to 721.476 newtons, which if I look at it in terms of 3 sig figs, 721 newtons. So it's pretty big. 445 newtons is equal to 100 pounds. So this is more than 100 pounds of force this woman would suddenly be holding in her hands trying to hold up. It's very difficult.